Welcome to lesson 3.4. Today we're going to talk about molar mass and look at how we use molar mass to solve problems. Molar mass is defined as the mass in grams of 1 mole of a compound, and molar mass is obtained by summing the masses of each of the component atoms. Ionic substances. So ionic substances are defined by something called formula units, and we use formula units when we calculate molar mass as well. Ionic substances can have simple ions like sodium ions and chloride ions, or they can have polyatomic ions, and the first example we're going to work through has a polyatomic ion in it. So calcium carbonate, also called calcite, is the principal mineral found in limestone, marble, chalk, pearls, and the shells of marine animals such as clams. First thing we're going to do is we're going to calculate the molar mass of calcium carbonate, and then we're going to use that information to determine the mass in grams of a 4.86 mole sample, and then we're going to determine what the mass of the carbonate ions themselves is. First off, calcium carbonate ionic compound has calcium ions and carbonate ions. For every mole of calcium carbonate, there's 1 mole of calcium ions and 1 mole of carbonate ions. So if I were to say if I had a dozen calcium carbonates, there would be a dozen calcium ions and a dozen carbonate ions. The way to calculate molar mass, notice here we have a calcium ion, and these numbers here signify how many of each we have. So for example, in calcium carbonate there's 1 calcium ion, and so we take 1 times 40.08. Now a lot of times students will get confused because this says calcium 2+, and on the periodic table they know they're just dealing with atomic calcium, or calcium, plain calcium. Note though that the charge is a reduction or an addition of electrons, and if you recall, electrons do not contribute significantly to the mass. So calcium atoms are going to have the same mass as calcium ions. So anyway, we pull these numbers from the periodic table, we'll multiply that out, we get this over here. The 1 carbonate ion has a carbon and 3 oxygens, so we take 1 times the mass of carbon, 3 times the mass of oxygen, get 48, and we total these up over here. So the mass of 1 mole of calcium carbonate is going to be 100.09 grams. And on molar masses, a lot of times students will ask, how far do you want us to go out in decimal places? I prefer 2 decimal places on molar masses, and that usually helps you get better results in your answers. So there's the mass of 1 mole of calcium carbonate. That was the first prompt that asked us to answer. We know that our second prompt was how many grams are in, I think it was 4.86 moles. So just by looking at this, but we're going to look at the number and we're going to try to determine what our answer should be around. So 4.86 is about 5. So if we have 5 moles of this, we should have about 500 grams. To determine the exact amount, we're going to put that into a dimensional analysis, 4.86 moles of calcium carbonate, and then you can set up the molar mass as a unit factor. Notice here that since moles is in our given, then we want moles on the bottom because we want it to cancel out. So we know that 1 mole of calcium carbonate is equivalent to 100.09 grams of calcium carbonate. When we solve, we come up with an answer close to 500, just like we predicted. Note on the second part of the second question, it asks about the mass of carbonate ions. So if we have 4.86 moles of calcium carbonate, recall that for every mole of the formula unit that we had 1 mole of calcium ions and 1 mole of carbonate ions. So if we have 4.86 moles of calcium carbonate, we also have 4.86 moles of carbonate ion. So if we step back and just look at that piece of molar mass that talked about the carbonate ion, we know that the mass of 1 mole of carbonate ions is 60.01. And we do the same calculation, only this time we're just dealing with carbonate ions, again using that as a unit factor so that moles cancels out, and we end up with about 292 grams of our approximately 500 that is carbonate ions. Another molar mass question. Isopentyl acetate is the compound responsible for the scent of bananas. Interestingly, bees release about 1 microgram or 1 times 10 to the negative 6 grams of this compound when they sting. The resulting scent attracts other bees to join the attack. Question is, how many molecules of isopentyl acetate are released in a typical bee sting, and then how many atoms of carbon are present? So we're given grams. We're going to need to go to the common language of chemistry, moles, and from moles we can use Avogadro's number to get to molecules. So first we need to figure out the molar mass of the isopentyl acetate. And so if we have, and this is set up a little bit differently, but I would set it up the same way we did the last time. Let's look at carbon. We're just going to take the number of carbons we have times the molar mass, so 7 times 12.01. Hydrogen, 14 of those times the molar mass of hydrogen. Oxygen, 2 of those, and we come up with a total of 130.18 grams. Now we use that to figure out how many moles we have. So again, there's that conversion factor. Only this time we put the molar mass on the bottom. We put 130.18 grams on the bottom because we needed grams to cancel out, and we wanted to get moles. We're going to take that times Avogadro's number to come up with that's the number of molecules of the isopentyl acetate that we have in that very small sample that the bee releases. That's how many molecules of the isopentyl acetate we have. The next question asks how many atoms of carbon are present. Well, instead of using Avogadro's number, we know that in every molecule there are 7 carbon atoms, so we can just take it times 7. Please note this, they added this slide, and I think this is interesting. So the answer, what they did is they truncated all of the numbers to have the correct number of significant figures. And so they ended up with 4 times 10 to the 16th carbon atoms when they did that. If you actually carry the numbers all the way through the problem, your final answer rounds to 3 times 10 to the 16th. So be very careful about truncating numbers too early. Okay, on this exercise, what I'm going to do is I'm just going to pause the slide for a little bit, or you can actually stop the presentation and calculate the molar mass of the following samples. So notice that in both of these, the nitrogen is the darker blue, the hydrogen is the lighter blue, and so you basically have to count and calculate those molar masses. Okay, so if you didn't get those answers, please double check with me or perhaps run those calculations again. Now the next question is, what number of nitrogen atoms are present in 1 gram? So you'll run this one just like you did the isopentyl acetate, where you go from grams to moles, then you go from moles to molecules, and then to atoms. For which of the following compounds does 1 gram represent 2.27 times 10 to the negative 2 moles? So what you would do is you would calculate this by taking, because normally what you do to determine moles is you would take 1 gram, and then the next step would be 1 mole over the molar mass equal to the number of moles. And so this time you're just looking for that middle number. And so what you're actually looking for is you have 1 divided by the molar mass equals 2.27 times 10 to the negative 2. And so to solve that, you would take 1 and divide it by 2.27 times 10 to the negative 2, and you would get 44. And if you look down through here, this one's 18, this one's 17, this one is about 30, and so the only one that's 44 is carbon dioxide. And on this one's a little bit simpler setup, doesn't really involve as much algebra. If you remember that the units for molar mass is grams, per mole, then you just can simply take your number of grams and divide it by your moles, and in this case you will come up with 160, which is the molar mass of bromine. So just that's a very handy tool to remember that the molar mass is represented by grams per mole. This one's a little bit harder. What you would do is you have 100-gram samples of all of these compounds, and so you would take those 100 grams divided by the molar mass of each, figure out which one had the greatest number of moles, and then you would take that number of moles times the number of oxygen atoms in each, and you're going to find that water wins simply because it has the lightest molar mass of any of these compounds. So the correct choice for this one is water. If you have questions on any of these, please make sure you get some help either from your instructor or a tutor. Next time we'll talk about percent composition, which will lead us into empirical formulas, but I encourage you to practice as much as you can on calculating molar masses of compounds.